Okay, students, now in the second part of this video, I am discussing from question number 24. I am discussing. Okay, the best graph shows the variation of G from the center of the earth to the surface is, students, remember this one, the right. Here it is like this. Up to surface, it is R equal to R. G is directly proportional to what? R. But beyond this, G is inversely proportional to what? 1 by R square. Same graph you are getting in the electric intensity also. So that this is the right graph. Next, 25th. Here. By which curve will the variation of the gravitational potential of the hollow sphere? Remember, potential is always negative, that is, negative means it is not possible. Of course, here also negative is there, here also negative is there. Remember, students, the gravitational potential is constant up to what? Surface. That's why in the previous question I discussed I equal to d by dx of v equal to what? 0. Intensity equal to 0 means differentiation of this quantity must be what? Constant. That means potential is what? Constant. Up to what? Up to its surface. Next, what happens now? It will be like this. So that this is the right graph. 25th. If G is the acceleration due to gravity on the Earth's surface, the gain in potential energy of the object of mass m raised from the surface of the Earth to a height equal to radius r. Okay, first I will draw the diagram. This is your surface. Here, object is moving some height. What is the height here? This is h equal to what? R. Here the potential is energy U1 and here the potential energy U2. You know the formula, U equal to minus G mm divided by what? R here. First U1 equal to, can I write like this? G m divided by R means capital R on the surface. This is the what? Surface. It is surface. And another one is at this height on this surface. Here for this, from here to here, it is R plus of what? R. U2 equal to minus G mm divided by what? 2R. Remember, students, as you go above, potential energy is always increases. So that delta U equal to U2 minus of U1, that is minus U1. Substitute this, minus G mm divided by what? 2R plus G mm divided by what? R. Simplified. So that delta U equal to G m divided by R into bracket. This is a common factor. Here also it is a common factor here. So that minus 1 by 2 plus of what? 1. This delta U equal to it is a plus, of course, G m divided by what? 2R is the formula. But all answers are in what? Small m is there, no? And G is there. For that, we know one relation, G equal to Gm divided by R square. This is the relation. This quantity Gm by R equal to G into R equal to Gm divided by R. So that here I am writing delta U equal to what I can write? Gm, and this is R equal to what? G R m divided by 2. This is equal to m G R divided by 2. This is the right choice. Next, 27th topic. If the satellite is stopped by suddenly in its orbit and allowed to fall freely on the Earth's surface. Okay. And height has given what? H equal to R. So more problem tough it is. Okay. This is the what? Radius R. Okay. Satellite is rotating at a height of what? H equal to what? R. Here I will call it as a what? Initial state, and this satellite, it is falling from this to what? This it is falling. Okay, fine. First, EI equal to kinetic energy plus of what? Potential. This is the initial, means at the surface. This is equal to 0 minus Gm into m divided by distance. This is the distance. What is this distance here? 2r. This is what AI equal to. This is equal to Gm divided by what? 2r. This is equation number 1. Somewhat tough it is. Final means this surface. This is the final surface, no? EF equal to KF plus of what? UF equal to. Okay. Here of M into what? V final square minus GM M divided by R I am writing because this distance is what? R. This is equation number 2. And we know that according to law of conservation of energy, initial energy equal to what? Final energy. So that equation 1 and 2 I will equate it. Gmm divided by what? 2r equal to what? 1 by 2 m of what? Vf square minus Gmm divided by what? R. Here this m get cancels. Then what will get? Gm divided by 2r equal to 1 by 2 Vf square minus Gm divided by R. To make simplification, I will multiply by 2, I will multiply it. By multiplying this to get cancels, so that Gm by R. This is, here also 2 multiplication, Vf square. Here also I am multiplying by 2 Gm divided by R. You see, this term I am bringing on this side here. Okay. That means and I made mistakes here. Okay, then simplify it. Then of m square equal to 1 by 2. It comes now. Okay, I made mistake here. It is minus terms. This is the minus. This becomes 2 Gm divided by R minus Gm divided by R. Gm by R equal to Vf square. So that therefore Vf equal to what? Gm divided by R. This is equal formula square root of G into R, because we know that G equal to Gm divided by R into what? R square. Using this becomes G into R. Substitute the value of radius and substitute the value of G. 9.8 into 6400 into, it is radius is what? 3 kilometer to meter. You convert it, then you are getting the answer is 7.9 into 10 to the power of what? 3 meter per second. Or else you can calculate, sir, is it the 1 minute? How can it's possible? Remember students, the orbital velocity on the surface of the earth is nearly 8 into 10 to the power of 3 is there. No need to do all these jobs. Important points, students. Orbital velocity. One should know some basic things. One should know. Orbital velocity on the surface of the earth is always 8. So that you can save your timings. You can save it. 28. I did in the regular class. I did start. Here, first you have to calculate what is this value you have to calculate. This is A, this is B, this is C, this is D. What is this value? Rectangular value. It becomes, this is A, this is A. It becomes A square plus of A square. A square plus of A square. It becomes square root of 2 into what? X. Square root of 2 into A. But I need, this point is required. This distance is required. This distance, this distance, this distance. So that this will be what? A off of this. So that AP equal to BP equal to CP equal to DP equal to, it is square root of 2 into A by 2 equal to A by root 2. It becomes, distance becomes D equal to A by root 2. This is first thing. Next. What is the force between these two? We calculate. F equal to capital G M into M divided by D square. D square is nothing but A by 2. It is A by 2. This is F equal to G M square by A into what? 2. What is this force here? F of AP equal to. It is like this. Similarly, you students, here no, don't waste your time. It is 2 times, 3 times, 4 times is that, no? So that F of BP, this I will call as a F. This will be 2F. This will be 2F. This will be 3F. This will be what? 4F, like this. Don't waste your time. Next. Here, draw this diagram. Here. Diagonal, this will be like this, this will be F, this will be 2F, this will be 3F, this will be what? 4F here. What is the resultant of these two here? These two resultant, it is like this. It is a 2F, it is the resultant of this. What about resultant of these two? It will be, again it is what? 2F. 2F. This will be the resultant of it. What is this angle? 90 degree. Why? This is 45. This is 45 degree. This is what? 90 degree. So that F resultant equal to F1 square plus F2 square. 4F square plus 4F square plus of 2 into 2F into 2F into what? Cos of what? 90 degree, that is. You know one standard formula, R equal to square root of what? P square plus 2Q square plus 2PQ into what? Cos theta. This is the formula standard. This quantity, it becomes 0 here. When this is 0, FR equal to square root of 8F square. This becomes 2 root 2 F, it is 2 root 2 F. This is the answer. Check it. 2 root 2 F. This one 2 root 2 F. Yes, this will be the right choice. Because F means what? We know this. We know this equation. Multiply what? 2 root 2. So that this will become 4 root 2 of this. Because I know that F resultant equal to 2 root 2 into what? F. This is 2 into root 2. What is F? We know this. G M square divided by what? A square into what? 2. 2 into 2, 4. 4 into 2. That's it. Next. 29. Acceleration due to gravity on moon is 1/6 of the acceleration due to gravity on the what? Earth. If the ratio of densities of, as given here, this relation G is directly proportional to R into what? Root 2. Now, you have to find it. The radius is asking, so that G of moon divided by G of 1 minute. G of moon divided by G of earth equal to R of moon divided by R of earth, rho of moon divided by R of what? But now you have to find this relations. You have to find it. Can I write R of moon divided by R of E equal to Gm divided by Ge. This term I will transfer it, rho of E divided by rho of what? M. Rho of E by M has given here. This is 5 by what? 3 here. And G of moon equal to G of moon on G of earth has given what? 1 by what? 6 has given here. 1 by 6. This becomes what? 5 by 18. What is 5 by 18? Where is that? This is the right choice. Next. The depth D at which the value of acceleration due to gravity becomes 1 by n times the value of at the surface. Yes, given this. Okay. G dash equal to 1 by n times of what? J. Use the equation. G dash equal to depth means 1 minus D divided by what? R. Here G dash by G equal to 1 by n. This one is the G dash by G equal to 1 minus D divided by R. It is 1 by n equal to 1 minus D by R. Then substitute. Then D by R equal to 1 minus 1 by n equal to n minus of 1 divided by what? N is that. This is D by R. Therefore, D equal to R times of what? N minus of 1 divided by n. This is the right choice. 31. A body is projected at height h equal to r from the Earth's surface. What is the escape velocity of a body on this? And he's asking this. I'll tell you one shortcut method. This is your surface. Escape velocity is E. At what distance is asking? At what distance? Okay. H equal to r. This is what h. H equal to r. Remember, when the h equal to r, g dash, it becomes g by 4. Remember. And another formula you should know that as you go above the Earth's surface, escape velocity v dash v will be less than this. Less than this. So that less than this means it should be divided by this one. And escape velocity equal to square root of g into what? R. You know this formula. But on the surface, ve dash equal to square root of g dash into what? R. R plus of what? R I am writing. R plus R I am writing. Why? This distance we should know that. ve dash equal to square root. What is g dash? I told you is easiest method. G by 4. This will be what? 2 into what? R. Can I write like this? Square root of 1 by 4 into what? Gr. Here square root of Gr, can I write like this? Ve dash equal to 1 by 4 means 1 by 2 into square root of what? Gr. This is equal to 1 by 2 of, sorry, it is equal to 1 by 2 of what? Ve. So that this must be F, nothing but F, nothing but 1 by 2. Am I made any mistake? No, I made one mistake. Okay, 1 minute. Just, it is not possible. 1 minute. Okay. escape velocity of body from the height. Okay, height. Yes, okay. EI plus UI equal to what? 0, because body is escaped. Final energy will becomes what? 0 in this point. Yes. Initial energy equal to final energy. M into what? VI square minus GM divided by R equal to what? 0. Okay. This M, okay, of M into what? VI square equal to GM divided by R. So that this M get cancels. Then VI square equal to 2 into GM divided by what? R, that is. Where V is the escape velocity from the Earth's surface, he's asking. Now, 2GM equal to VI equal to what you are writing? Square root of 2GM divided by R. Okay. We know that G equal to GM by what? R square. G into R equal to GM by R. Substitute this. VI equal to 2. This is quantity is nothing but GR. 2 into what? GR. Okay. Initial velocity. How much is given? F into VI equal to F into what? VE has given. Okay. Square it, students, this one. Square it. VI square equal to 2 into what? GR. This will become F square into VE square equal to 2 into what? GR. Then I multiply and then. Okay, that's somewhat I'm getting confused. That I will do equal to what? 1 by root 2 times n of s. Okay. Next. 32. The escape velocity of a body on the Earth's surface is V. A body is thrown with a speed square root of VE. Okay. The velocity of a body at the infinite distance. At infinite distance. Final velocity is asking. Here, V final equal to square root of one formula is there. Shortcut method. VI square minus of what? VE square. This is the formula. This is equal to VI. VI equal to what? Square root of 5 into what? V is that now? Square means 5 into what? V square. So that 5 V square minus what? V square. V square equal to square root of 4 V square equal to 2 into what? V. So that V final divided by VE equal to 2. Final nothing but infinity. You can write V infinity divided by VE equal to what? 2. This is the right choice. Next, this in the regular class I told you, T square is directly proportional to what? R. Some of them, their argument is what? Yeah, is it not straight line passing through this origin? No, it will not pass through the origin. The right answer is this one. 34th. This is the revolving around the planet of mass m to transfer to circular orbit of radius r1 to what? R2. This is r1 and this is what? R2 here. Here you write u1 equal to minus gmm divided by r1. u2 equal to minus gmm divided by what? R. Then use subtract and all that, then you can calculate. This becomes what? 1 by R2 minus of what? 1 by R1, that is. Kinetic energy is asking, no? Okay. Kinetic energy is half of the what? Potential energy, that is. Okay. First, kinetic energy on the surface 1 equal to Gmm divided by 2R1, kinetic energy. And kinetic energy here on this surface equal to Gmm divided by 2 into this distance is what? At a height of what? This will be R2, it is. But remember students, always the kinetic energy, as you go above, it will be decreases. That means kinetic energy on the surface 1 is greater than the what? Kinetic energy of what? 2. This is the relations. So that difference in kinetic energy is equal to this one. Kinetic energy 1 minus of what? Kinetic energy what? 2. This is equal to Gmm divided by 2 into bracket 1 by R1 minus 1 by R2. 1 by R1 minus 1 by R2. This is the formula. This. Actually 2 is missing, that is. Okay. Next. An asteroid of mass m is approaching the Earth initially at a distance of 10 r, okay, with a speed of vi. It hits the Earth with a speed vf is asking, it is. Okay. Lengthy problem it is. I equal to 1 by 2 m into what? Vi square minus G m divided by distance is 10 r. This is equation number 1. Then E final equal to half m into what? Vf square minus, it is surface now, Gmm divided by r. This is equation number 2. Okay. Now, according to law of conservation of energy, I equal to what? Ef. Simplify it. 1 by 2 m Vf square minus Gmm divided by r equal to half m into what? Vi square minus Gmm divided by what? 10r. Here m get cancelled. This m get cancelled. What is left? 1 by 2 Vf square minus Gm by r equal to 1 by 2 Vi square minus Gm divided by what? 10r. Again multiply by 2 on both sides. So that Vf square minus 2Gm by r equal to Vi square minus 2Gm divided by what? 10 here. Multiply by 2. Then next, Vf square equal to Vi square, okay, this factor. This term I am bringing on the other side, minus 2Gm divided by what? 10 plus r, of course. It is 2Gm divided by what? R. This is the common factor here. So that Vf square equal to Vi square plus 2Gm divided by r into bracket 1 minus 1 by 10. Is the choice? Is the right choice? Not this one. 2Gm by r, 1 minus, both are same now. Okay, it is also same. Both are either you can write this or this. Both choices are wrongly distributed. Either you write C or D, that is. Next, last more 36. Potential is given. We have to find the gravitation intensity. Gravitational intensity equal to d by dx of what V. I equal to d by dx of what this quantity. 3x I cap plus 4y j cap plus 12z of what k cap. This differentiation of x becomes 3i plus of what 4j plus of what 12z it becomes. This is I. But I want to find the magnitude of this equal to square root of 3 square plus 4 square plus of what 12 square equal to, substitute this, 9 plus 16 plus 144. It is altogether, it comes around, it is square root of 169 equal to 13. That is what? 13. This one. Newton per kg. It is just like simply F equal to Q into E you are writing now. Same gravitational force F equal to M into E or I you can write. Therefore, I equal to F divided by 1. What is the F? Newton. This is what? Kg. That's 37. A particle is fired vertically upward with a speed of 15. You see, initial speed is more than the escape velocity. Whenever the initial speed is more than the escape velocity and it enters into the interstellar space, give the equation final equal to square root of vi square minus v square. This is the shortcut method. This is equal to square root 15 square. It is what? 225 minus. It is what? 11.2 square. 11 square means 221 roughly. Just to calculate yourself, it becomes it is nearly, it is what? 10 kilometer per second. It is what? 10 kilometer per second. How to do this kind of problems? It is nearly 225 minus of what? 121 or 125. It becomes 100. Square root of 100. Square root of 100 equal to what? 10. Last. The escape velocity from the earth is v. A body is projected at a speed of 2v. Same thing. Initial velocity is more than the what? Escape velocity. It will enter into the interstellar space. What is the final velocity? Vf equal to same vi square minus v square. Same thing. Equal to, it is 4v square minus of v square equal to square root of 3 into what? That's the right choice. Okay, now I'll stop my discussion.